Hi guys, my name is Wang Zining.
My name is Elena.
My name is Li Huizhen.
My name is Tan Hui Shan.
Okay, thank you for you guys coming to the meeting. This is our group discussion for the game development project proposal. So next I will share my screen to briefly introduce our project. So this is our project. For this task, we are required to create a new idea and then analyze the object and classes involved in the game development process. And today we will go through a few key points. The first one, we will brainstorm the concept for our game, include the title, storyline, gameplay, and also the player mission. And next, we will identify the main classes and objects involved in the project. And last, we turn to the analyze the class relationship, which such as association relationship or inheritance relationships. And we will justify why those relationships is suitable. So next I will create a whiteboard. So we have decided to propose a game idea which called the BrickRush. Let me spell like this. So why we call it BrickRush is that the bricks directly reference the classic Tetris-style blocks, often called bricks in casual gaming language, for the rush means as a sense of speed, pressure, and excitement, to fitting for a game where players race against time or descending pieces. It also hints at fast-paced gameplay, which is common in advanced Tetris or arcade-style puzzle games. Next, I will show a video about the Tetris games. So, this is a puzzle game where different shapes made of square, we can call it tetrominoes, it falls from the top of the screen, and the player's goal is to fit these shapes together to form complete horizontal lines. And these lines are clear when they are completely filled with blocks and have no empty spaces. Yeah, like this. So when the lines are clear, the players will earn points. So to help with strategy, we also show the next upcoming block on the screen to allow the player to plan ahead and make smarter decisions as they play. So the most important thing is the player must avoid letting the blocks pile out to the top. If the blocks land above the top of the playing field, the game is over. So the core challenge is spatial awareness and quick thinking. The players must rotate and position blocks to avoid gaps and clear lines. Next, I'll pass my part to Leno.
Now we are going through the gameplay of our game. So let's start with control. So we will set the movement commands using the arrow keys. So player can use the arrow keys on the keyboard to move and rotate the blocks. Okay, so for example, by moving the left and right arrow key, the player can move their block in specific direction. For example, left arrow key will lift to left side, right arrow key will move to right side. And also we have set the up arrow key as the control to rotate clockwise. So for example, initially the block looks like this. So after a rotation, the block will become like this. However, we have also set the down arrow key as the speed up key. So if the player feels like the block is moving very slow, they can just press down arrow key to make the block move faster. Okay, so now I will be explaining how the gameplay works on this whiteboard screen. So as the block falls, then the player's goal is to make a complete line. So this is a sample of a complete line. So once the line is completely filled, it will be clear from the stake. So by this, the player will earn 10 points. So that's how they can collect their points. So if the player can clear multiple lines in a time, for example, the player is clearing 2 lines at a time, then the player can receive a extra bonus point. Also, when these lines are being cleared, they will be removed from the stake, and the new block will, will drop down. So this gives the the stake to have a bigger space and giving a player to have more room to work with new block and they can collect more points. Okay, so to help with this strategy, to help with the game strategy, we will be also showing the upcoming block on the screen so the player can plan ahead and decide their next move. So the game will continue as long as the state of the blocks are not being filled to the top of the screen. So once the block has reached this place, the top of the stake, so this means that the game has ended. So the player will lose it. So that's the brief on how our game will be played. And now I will be passing the season to Huisan and Huizen explain about the UML diagram. Thank you.
Okay, let's talk about the classes and objects in our game BrickRush. So to build the game, we need a playing field, right? That's where the grid class comes in. For the grid, we're using a cells 20 by 10 2D array. Basically, it's just a 10 by 20 matrix where each cell holds either 0 or 1. If it is 0, the cell is empty. If it is 1, it means there is a block there. For the methods, we came out with 3 main ones. First is occupied as white to check if a specific cell is filled. Second is lock piece determinant, which lock the determinant into grid when it can't fall anymore. And last is clear line, full row, clear them and move everything above down.
Yeah, and now let's look at the shape themselves. We got a class called Determinal as the best for all the blocks. It's an abstract class because it has a virtual method called subshape and we override that in the subclasses. It also includes blocks, which are the 4 squares that make up the shape, as well as X and Y for the position, and also the color for visual appearance. There are also share methods like move left, move right, rotate, and draw. These methods are very useful and also used by all the shape. Then we have 7 subclasses: S block, L block, T block, O block, Z block, I block, and also L block. Each one overrides set shape to define a different layout. For example, I block is a straight line and T block has a T shape. The rest follow the standard Tetris shape. This shows inheritance because all shape types share the same base structure from determinant. And we use polymorphism in the game class because we store the current shape using a determinant pointer. So it doesn't matter which subclass it is, we can treat them all the same way.
Yes, and after that, we look at the game class. That one basically control everything. It managed the game loop, score, current piece, and all the interaction. It got a few important attributes. There's the grid, of course it is on that directly. Then there's current piece, which is a pointer to the current falling terminal. And of course, score, just an integer to track how many points the player earns. For the methods, we got run, which is the main loop, update to handle game logic like movement and live cleaning, and draw to show everything on screen. And in terms of relationship, game use composition for grip. Since the grid is part of the game and doesn't exist on its own, it also uses aggregation with the terminal because it holds a pointer and can be changed shape anytime. So yeah, that's how we structure our game using object-oriented programming. It is clear, flexible, and follow the concept we learned in class, like encapsulation, inheritance, polymorphism, composition, and aggregation.
That's all about our classes and relationship. Thank you.